Hi there, and welcome back to another lesson in BCIT's Technology Teacher Education 4010 class. And today we're going to be talking about serial communication. Um, sorry. If the pun starts out like that, you know it's just going to get worse all the way through. Yes, we are going to be talking about serial communication, but serial with an S, not serial with a C. And serial communication is one of the ways that you can get information off of your Arduino and back to the computer. So it's a very useful tool for troubleshooting, for reading data, and doing all sorts of useful things. Another way that we're going to get some information off of our Arduino is using the LCD screen on your big bad breadboard board. And as you can see, there's a number of wires that hook up to here. And this screen uses something called parallel communication. So we're also going to be talking about parallel communication and serial communication, and basically how we can get our little Arduino to talk to the big wide world. Okay, so we're going to start, as we have for the last few lectures, by going into the Tinkercad Arduino simulator. And you should know by now that you've got set up an account on Tinkercad. And then you can come in here, and when you've got your account set up, you'll be able to access the Tinkercad simulator, which is a really great tool for taking a look at all things Arduino-ish. And actually, I can get rid of the, let's see, which display is that? Right there. Let's just turn that off for a moment. And now we've got the full Tinkercad screen available to us. So one of the things I like about Tinkercad is you can do this anywhere, so you don't have to have your Arduino with you. A little later on, we're going to do some of this stuff for real, and we're going to take a look at how to make it work with your real Arduino and on your real computer. But let's follow the simulation because it works really nicely. So log in with your Tinkercad account, and in here I've got the circuit that I was using in the last lecture, where we're just fading some LEDs in and out using the analog write command. Okay, so what we're going to do over here is we're going to take a look at our code now. Uh, Actually, we're going to take a look at our code. And in here, I've just started with a blank program. Now I've got blocks and text turned on because when you're just starting out with programming, it's nice to have the blocks here, but it's also nice to be able to see what the code looks like when it comes in. And actually that brightness variable was from a previous one. I can get rid of that. Just delete that variable. Go away. There we go, delete the brightness variable. So this is what your code's going to look like when you start up if you've got nothing else in there. Okay, so now what we want to do is we want to take a look at how we can get data off of the Arduino. Now, the data comes back through to your computer through your universal serial bus or USB. And you'll notice that word serial showing up again. Now, what serial means is that the data is coming through one bit at a time after the other. So serial means in line. The word that pops to mind right now is serial killer. That's a bad analogy, but you can come up with other uses. But it means something's happening one after the other, and we're transmitting our bits. Last lecture we talked about bits and how it takes 8 bits to make a byte. Okay, and one byte is about the size of one character or one number or one piece of information that we'd send back and forth. So we're going to send those bits, which are either on or off, down this line right here. Now, the Universal Serial Bus Protocol, and the protocol is basically the language, the commands, the rules that the computer uses to talk to the Arduino, is a fairly complex one designed for high-speed communication. And you've got a little chip on your Arduino right here on on brand name Arduinos, it's actually another Atmega microcontroller, but on some of the less expensive ones, it's a little chip called CH340, and you have to have a special driver installed for your CH340. And what it allows you to do is it allows you to use a traditional um, serial protocol over the fancier, faster universal serial bus. Bottom line though, We're sending 1 bit of a data at a time. And you'll notice we've got a couple pins on our Arduino labeled TX and RX. And those are connected to the pins on your microcontroller. Okay, if you follow the little trace through on the printed circuit board, you'll see they connect to pins on the microcontroller. And when you execute a serial communication command with the microcontroller, the pins will flash on and off really rapidly to transmit data, and it goes out to here, but it also comes back to this chip, and this chip interprets it and fires it down this line, and it shows up on your computer, and you can watch it in something called the serial monitor. Now, I was running something earlier, so I have to clear my serial monitor right here, but your serial monitor is software running on your computer that's receiving the data. Actually, it can transmit data too, but we're not going there today. Today, we're just going to have the computer listen and the Arduino talk. The cool thing about serial communications is that it's baked into the Arduino, making it very easy for you to do. And so in Tinkercad, come in here and click on your output tabs, and you'll see that there's a command right here that says print to serial monitor, and just put this right here, okay? And there we go. We drag that out here, and in computer language, hello world is the standard term for the first thing you do to get your computer or your microcontroller or anything like that to communicate with the outside world. So you'll see hello world programs in pretty much every computer language out there because it's really important to be able to communicate. And you'll see that when I dragged it in, we got some code showing up here because I've got the blocks and text turned on. So if you don't have that, if you're just seeing the blocks like that, come up here, turn on blocks and text, and now you see the text-based version of this showing up. And you'll notice that the first command it puts in here is in serial.begin. And that's serial with a capital S, not serial with a C. Okay. And then it's got this number right here, 9600. Okay. Now, 9600 is the baud rate, we'll call it. It's the number of bits per second. And real electronics geeks will get in and say, well, baud and bits per second, and they'll get into the differences between them. But really, you're sending 9,600 bits per second down that data line, which at first glance sounds really quick. You're turning that switch on and off well over 10,000 times a second. But in terms of actual communication speeds, that's pretty slow. Okay. The nice thing about being slow is just as when you speak slowly, you speak more clearly and make it easier for other people to understand. When you transmit data more slowly, the receiving device, you have a more robust communication protocol. 9600 is a pretty good standard for sending small amounts of data relatively reliably. As you get going faster, the Arduino can handle speeds up to 115K BPS or 115,000 bits per second. This is 9,600 bits per second. Now, you can find out more about the serial communication protocol online. There's some great videos and discussions about how it works. And so I'm just going to refer you to SparkFun. Really good website for people learning about electronics and learning about microcontrollers and programming. And they have some great tutorials in here. So if you go to the SparkFun website, learn.sparkfun.com, and go into their tutorials, you'll find the tutorial link right there. You'll find one on serial communication. And it's got some neat charts of how it turns. Your computer is going to be turning on and off the pins to send data when the pin is high at the 5-volt state and low at the 0-volt state. And you can go down here. They've got all sorts of other tutorials that you can look at. Like I say, this is a great resource and interesting to look at. The hexadecimal and ASCII, good background information on here. But then there's some rules of serial down here and how the actual communication protocol works. So if you'd like to know more about serial communication and what RX and TX mean and how they're all hooked up, go ahead and take a look at that tutorial, and you'll even find out why this term, the universal asynchronous receiver and transmitter, is so common in microcontroller communications. Basically, UART means you've got a serial port. Anyway, I won't scroll through there too much more. Um, let's come back to our circuit right here and take a look what's happening right here. Now, when you type this in, I just want to point out that there is a capital at the beginning of serial and not a capital at the beginning of begin. Arduino cares about capitalization. So drag and drop takes care of it for you, but if you fail to capitalize something, you'll have a problem. Now, down here, you can see that we've got serial.println. Now you'll notice that over here, I said I wanted to print this with a new line. Okay, so we'll take a look at the impact that that new line and the ln at the end of our print statement does in just a moment. Let's change our delay up just a little bit. The delay of 10 seems, well, we're going to get a lot of data flowing in there if we have a delay of 10. Where is my delay statement in here? This is why I like typing things in. Control, oh, there we go. Wait 1 second. Okay, so now we've got delay of 1000 in there, and let's start our simulation. Now, right now, you don't see very much happening, okay? Except if you click on your serial monitor button right down here at the bottom of the screen, every second, you'll see hello world pop up right in here. Now, it doesn't have to be hello world. We can stop the simulation and we can come in here and we can put something else in there. Hope you're having a nice day. And start that simulation up. And now your computer is wishing you a nice day. So let's take a look at what's going on right in here. Now, serial.println, this is a function like one of those subroutines that we've written before, but in this one, somebody's already written it for you and it's baked into the Arduino code. So when you do this, the serial object, okay, so when we go serial begin, we're setting up a serial object and the object knows that it's going to communicate at 9600 bits per second. And then down here, the object has a function or a routine called println that's we're going to pass some data to. And so it knows how to print, but it needs to know what to print. In here, we've put our words between quotation marks, okay? And that means it will print exactly what we put in between the quotation marks. If we don't have quotation marks, it's going to be expecting a variable, so we can print out a number. I'll show you what that looks like in just a moment, okay? But now it's wishing you a nice day, and it's doing that every 1,000 milliseconds, and it's popping up right down here, and it keeps going on. I said we was going to take a look at what happens if we get rid, oh, let's just drag that up over here a little bit, and let's say without that new line, okay? So let's start that simulation without the new line, and you'll notice the ln is gone from in here. And basically what's happening now is it's not going and pressing the carriage return on there. So, so you can either get a carriage return after each statement or not. And if you don't have it in there, all of a sudden that starts to get really, really wide on your print monitor. Now, we can use this to do some really neat things. I'm going to stop the simulation right here, and I'm going to clear my serial monitor, okay? And you'll recall that in the past, we used a repeat statement to make a for loop, okay? And the for loop comes around here, and there's a variable called counter that it's using to keep track of things. And let's see. Let's create a variable called counter so that we can actually access it right in here. Oh yeah, it goes and changes. There's a reason I like typing things in here. I'm going to change the name of this variable to X. X is just easy to use. There we go. So what we're going to do is, now what we're going to do is, instead of printing, hope you're having a nice day, we're going to print our variable X. Let's delete that out of there, and let's put X right into there. There we go. And we'll put a new line after it. Okay, and now you'll notice those quotation marks are gone. So it's going to print our variable x, and then I'm going to do a little bit of math, and I am going to say, where are we here? We are going to come in here and we are going to increment x by 1. Where are we right in here? Um, we have to variables, oh, change x by 1. There we go, right in there. So now what you see we're going to do is this loop is going to go around 10 times. Each time we do that, x is going to increment by 1, and it's going to keep going up. So let's see what happens. Now on your serial monitor, every second, it prints out a new number down there because x keeps getting bigger each time we loop around through here. So the program runs in here, it'll do this 10 times, and it will print x with a new line character after it, so we get that carriage return, and then we change x by 1 right here. Wait a second, and now we're on up to 11, and this just keeps looping around and around and around. Now, if we only wanted to count to 10, then what we could do, or let's say we wanted to do a countdown, I'm just going to stop this simulation. If I start this out here and I set x at 10, and I change x by -1, let's change this delay down so it goes a little bit faster. Okay, and now we start our simulation. Now we've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 repeating over and over in our serial monitor because we come in here and it starts with x equal to 10. We do this 10 times. We keep reducing x by 1. We print x, and then we come down here. We take our little delay after we've done this 10 times because everything in here is in between these squiggly brackets or ellipses. The squiggly brackets or ellipses represent this hug that you see going on right there. And right in there, we're getting our countdown happening. Now, you can add a few interesting features in here with your serial print. Let's come to our output, and let's add another command right in here. And instead of hello world, we can say countdown is, and get rid of that new line in here. Okay, so if we follow this code right through here, so x starts at 10, this is our for loop, okay, which is going to execute 10 times because it says repeat 10 times. The serial print statement is going to print the literal. Literal is for anything that's not a variable, okay? So it's going to print out these characters. It's going to send each one at a time. It's going to translate that into a stream of bits. It's going to pump it down that serial line, flashing the pin on and off in the right pattern to represent a capital C, then a small case O, U, N, T, all the way down here. And then it's going to execute this command. It's going to go and it's going to find whatever value is being stored in the X character. And then it's going to start counting down right in here one at a time. And let's see what we get. And now we're getting text describing what's happening, and then the number coming along right after that. It's not so difficult. Um, if you can do that, what you're actually doing is a fairly sophisticated communication protocol, and you could take some fairly long wires and send that data down the line for a long distance. All right, let's take a look at how that might work on your real world Arduino. And to do that, we're going to start up the Arduino IDE. Okay, and let's just bring that window up and drag that right into here. Okay, so you've got your Arduino IDE set up. Now, in order for this to work, you are going to have your Arduino plugged in. So I'm going to turn on the other screen again here and make it a little bit bigger. Okay, and I am going to remember to hit the transition button this time. And now I've got my real Arduino over here, and somewhere I've got a plug that lets me plug this in like so. There we go. I've got my last code from the Arduino running right in here. You can see the LED fading in and fading out. Probably doesn't need that light on. Okay, now what we're going to do is we're going to copy this code because we know it's working in the simulator right here, and just take that code and copy, because if it works in the simulator, it should work in the real world. Delete all your code out of here and paste that code right in there. That should be the exact same code that we have there. Now remember, when you're uploading to your real Arduino, you need to know how to communicate with it. Now in the bottom corner of my window, it says I'm programming to an Arduino Genuino Uno on COM3. But if I come in here and I want to check, am I really on COM3? Remember that you come into Device Manager, okay, and in your Device Manager, you're going to see a window that pops up that looks like this. And somewhere in here, you're going to have your COM ports. Where are we in here? Ports, COM, and LPT. And there you can see I'm using a knockoff brand of Arduino because I've got the CH340 in there. It works perfectly fine. It's referring to this little chip right in here. That's doing the communication between the USB and my microcontroller right in here. Okay, and and we're good to go on here. So now I'm on COM3. I should be able to upload that onto my Arduino. It asks me to save it. I just click save. I don't give it a fancy name or anything like that. And what you'll see is you'll see some lights flashing here after it's compiled the sketch. Okay, and the lights that you see flashing are actually serial communications coming in right through here. And that's the data coming in from the computer, and it's flashing this pin over here, and it's uploading that in here. And now this light is flashing because this chip is sending data back down the line. And if you zoom in really closely, okay, it looks like that is the should be the TX pin. Mine says RX, but TX is for transmit, RX is for receive. Anyway, in your Arduino interface, come in here, and there is a serial monitor in here, just like there was in Tinkercad. And there we go. There's your data popping up on your serial monitor. Now, if that data is not showing up on your serial monitor, I dragged that in from my 4K screen, so it was really, really huge. Let me just resize that a bit. If that data is not showing up, just check in here that you've got 9600 baud selected. These are the various baud rates or bits per second rate that your Arduino is going to be happy communicating with. So leave it at 9600 baud, because if you go to something that's not quite there, okay, it'll reset and you'll get something like this, which is a little bit garbled. You're getting something in there, but it doesn't know what you're saying. If you've got the baud rate right, they're both speaking the same language at the same speed, and they know how to talk. Well, now you're getting data off your Arduino. This is really important because later on we're going to attach sensors to our Arduino, and you're going to want to be able to read the sensors on your Arduino. And transmitting data over the serial port is one way to get data off of your Arduino. You can also use the serial port to do all sorts of interesting things. Later on, I'll show you how you can use your Arduino to actually control things on your computer. There's some really neat stuff that you can do over the serial port. So your challenge, okay, is take this, give it a try, and I've got a countdown going on here. See if you can turn that around and make it count up. Or if you're a little bit more experienced with program, check out the command called millis. Okay, so on your Arduino help file, okay, take a look in there. There's an excellent reference set of data in here. And So the Arduino reference, the language reference comes in here, and you'll find a whole bunch of really interesting information on here. And if you take a look at millis, you'll actually be able to turn your Arduino into a countdown clock. Okay, so some very interesting thing going on in there. Some examples of millis that use the serial print command. So serial print, really cool thing to be doing with your Arduino. Now, I'm going to switch over to talking about your LCD screen in just a minute. And your LCD screen doesn't use serial communication. It's a little bit trickier, okay, and actually a little bit old school. But it'd sure be nice to have this fired up so that you can get data off of your Arduino without having to be connected to your computer all the time. The cool thing is printing to this actually works a lot like printing to your computer, and the code that comes in the Arduino IDE takes care of the fact that you're doing serial communications here, but you'll do parallel communications to this particular LCD screen. Okay, so go ahead, try the serial print, get that serial monitor up and running. You'll find lots of useful tutorials out there about all the different things you can do with the serial print command. Now I'm just going to turn the screen off for a moment. Oh, that's me. Turn this off for just a moment right here, and let's clear this code out of here. Okay. Now you're welcome to save that if you want. And I'll get rid of my variables, just drag that up. Now, delete the X variable. There we go. And that can disappear, clear my monitor right down there. And I'm just going to get rid of this code window for a second because now we're going to tie in a new hardware component. And this is really exciting because the circuit design here, um, let's come down in here. Make sure that you've got all components turned on because there are a lot of really cool components in here. And later on, we'll take a look at NeoPixel strips. You can go figure them out now. They're really cool. Infrared remote control, so many cool things. Can only do so many cool things at a time. Drag this LCD screen right on here. Now, that should look pretty familiar because it should look a lot like the LCD screen on your big bad breadboard board. If you're not in TTED4010, you probably don't have a big bad breadboard board. That's okay. It's a device that we put together to hold all this in one place. Just get a parallel 16 by 2 LCD screen, and you can play along in the home version. Now, some of the lines on here, if you look at this, are pretty easy to figure out. So GND, okay, we think we know what that's going to do. Now, over here on this side of our Arduino, we've still got it hooked up. So we've got a line going in here, and this header all along here, and this header all the way up here are all connected to the black wires that go into the GND port of the Arduino. And anytime you have two devices trying to communicate to each other, it's really important that they have a common ground. Here we've got 5 volts coming along right here, and that powers this line right here. It comes along and powers this line up here too. So we're going to have a source of 5-volt power, and that's going to come in on our VCC line right up here. Now, okay, VCC is often used to indicate the power. We've got a button or a pin right here, and if you put your mouse over top of it, you'll see the little guide pops up and says contrast. And then there's a bunch of other interesting terms that come down here that we'll talk about as we go along down here. So let's take a look at how this is hooked up. Well, we've got ground that has to go into ground somewhere. Excuse me. Let's put it in there. Because it goes to ground, let's make sure it's black. And then we've got VCC, which is going to go into our +5. And because it goes into our +5, make sure that's in red. And I am just going to pivot this around so things line up a little bit nicer. Okay, so we've got black, and then we've got red right there. Now this V0 is an interesting one, or V0. This is our contrast button. Okay, and for your Arduino, I've got a little thing an actual potentiometer. And I'm just going to hold this up really close. You might see it more clearly. It's a little rectangular thing like that. In fact, let me turn the other screen back on. Well, I'll talk about that when we're hooking it up physically. On here, we're just going to take a potentiometer off of here and drag a potentiometer right up here. And this is going to allow you to control the contrast on your pin. So I'm going to put this in right here. Okay, I'm not going to put it in there just yet. I'm just going to put it there for a moment because I want to set one pin of it to be the +5 side and one pin of it to be ground. So I'm just going to come in right here and hook this in to +5 and hook this up to black. Okay, so now everything in here is +5, everything here is ground. I'm going to drag my potentiometer over here and put it right between those two. Excuse me. It is not a COVID. Um, So here we have our red line comes in here. This side of the potentiometer will be at +5. This side will be at ground. And as we turn the dial on our potentiometer when it's running, we can take this middle, the wiper, and kind of sweep it from the 5 side down to the ground side. And that's going to give us a voltage output that we can tie right now into our contrast pin, right down here. Okay, and for that, I'm just going to leave the wire green. Okay, so what happens is when we're displaying things on our LCD, if it's coming up too bright or too dim, we can adjust the contrast button. This is just like a little contrast dial that you'd have on an old black and white television or something like that. Okay, now that's got the first few pins set up for us. Now we're actually going to start making connections to our Arduino. And I'm going to use a yellow line coming right in here. And the yellow line is going to connect to our, where are we here? Our RS, our register select, which is right in here. And I'm going to run it this way because this is how we do it on our big bad breadboard board, but you could go straight to the Arduino. And so this yellow line comes in right here, and then we're going to run it back to our Arduino back over here. And our yellow line is going to come in and plug into pin 7 on our Arduino. You can bend that around, and let's just make that yellow. Now, what this is doing for us is this is letting the Arduino send a signal down here, and it's going to be part of our parallel communication circuit and how this talks to the Arduino. Now our next line is the read-write line, and because we're always going to be writing to the Arduino, we don't need to change it back and forth. We can just put that into ground, set that black so it's at ground, and then our next line in blue right here, the enable line is going to come up here, and I'm going to make that line blue just because that's the way it is on our big bad breadboard board. And then that one is going to come right back here and make that blue as well. And this is more communications between the Arduino and the screen. Now you'll notice that we've got 2 wires hooked up. Sometimes you can get serial communication going over 2 wires, but all of a sudden we're going to start adding a lot more. And the pins that we're going to add right now are down at the far end right here. We are going to use DB7, 6, 4, and 5 and 4. And DB4 is going to be on a brown line. So we'll bring that up right into here. And that will be brown. And that's going to come over here. And let's just run that into pin 5 and make that brown. And then we're going to take, that was DB4. And we're going to come up here, and this is going to be a white line. And then a white line is going to come right over here into pin 4. And then we're going to have DB6. It's going to come right up in here. And DB6 is going to be an orange line. Come down right here. And then finally, we've got another yellow line coming up off DB7. And that's going to come right into pin 2 and yellow. Oh, that's a lot of wiring. Okay, but we've kept it in the same color that we're going to be using on our big bad breadboard board when we do it for real. Now, yes, it was a lot of wiring, and that's because this is what we call a parallel interface. Instead of a serial interface where you've got one wire carrying all the data and the bits traveling along behind each other, in this case, we have 4 bits of parallel data. And what we've got in here is we've got a whole series of switches to help support them, the read, write, and the enable pin. So what happens is that when we talk to this screen, we set these bits either high or low the way that we want them. And then the enable pin says, okay, I've set all the bits, and I turn on, and then this chip reads 4 bits at a time. You'd think that a parallel communication system would be faster because you've got 4 lines transmitting data. And for a long time in the early days of computing, parallel interfaces were the fastest. In fact, when you go back and look in your device manager and it says COM and LPT, the COM was the serial ports on your computer, and the LPTs were the line printer or the parallel ports. And they were set up using parallel data lines because you could transmit more data that way. But as computers got faster and faster and faster, they got better and better and better at the timing of sending their pulses. And what started to happen is that you'll notice that each of these lines is a slightly different length. Data was being transmitted so fast that the length of the lines started to make a difference. And whether the line was twisted and kinked was making a difference in the data. So you couldn't pulse a parallel port as fast as you could pulse a serial port. Because if you pulsed it really fast, then you would get a discrepancy between the data on this pin arrived and when the data on this pin arrived. And so what they said was, well, if we've only got one line, it doesn't matter how long it is or how twisted it is, everything's traveling down there at the same speed. And as a result, serial communications over one line have managed to exceed the speeds of parallel communication over multiple lines. It's kind of counterintuitive until you think about the timing and coordination that's required right on here to make all of this happen. Okay, so that's a long explanation, and if you take a look at one of SparkFun's tutorials, you'll find more information on the parallel communications. You'll also find some great tutorials on using the LCD, both at SparkFun or here on the Arduino website. So if you need to go back and review some of the things that we're talking about here, go into your arduino.cc and dig around in their tutorials and look for the Hello World example program, because that's what we're going to use as the basis for our program. Now, you'll notice in here that they've used different pins for hooking up their LCD screen, which is perfectly fine. We're going to account for that when we hook it all up. And here's a schematic diagram of how they've got it hooked up. And here you can see those 4 data lines, and they all need to talk at the same time. Here's that potentiometer for setting the contrast. And they also have LED plus and LED minus plugged in. And I haven't done that because our physical LCD screen doesn't have an LED built into it. We may have to do that in order to see the one on Tinkercad. Okay, here we are back at Tinkercad. This is going to do nothing until we put some code on it. So let's pop this out and bring open our code editor. Okay, and now we're going to start to run into some problems right here, because when you go to your output and start looking up and down in here, there's print to serial monitor, but there's nothing in here about how to print to the LCD screen. So our drag and drop can get us so far. It worked great for serial printing, but we are now going to have to be bold and move away from the blocks and into the world of text. And it's going to cancel what we're doing. We're going to continue on right here. Okay. Now, in order to make the screen work, because not every program is going to be using a screen like that, we need to add some additional features. Okay, it's like you go and buy a car, and maybe you want the fancy stereo in your car, but most people don't. So you buy the option of this fancy stereo. Well, for code, that fancy option is a library, and so we have to add a library to our Arduino code so that we can handle a liquid crystal display. And so I click on this little file folder up here and I include the liquid crystal display, and you'll see this line shows up right here. Now, hashtag right on here is a command to the compiler, and include means go out onto my computer, look in the file folders, and in the libraries folder, you should find a library called liquidcrystal.h. And it's just as if you typed all that code into your program. Okay, it's available for your program to use, but you don't have to have it clogging up the entire screen. And best of all, you don't have to write it. Okay, we've got liquidcrystal.h right in here. Now, there are some example programs as well that you can use. Okay, so if you come over here and take a look at the Hello World tutorial, okay, you'll find example code for making this work right in here. And this is built into your Arduino software, but you can just come in here from the Hello World tutorial and copy, Control C, that should work. Come over here, delete all this, Control V, and here we go. Now you can see it's got some instructions in there. There's our include liquidcrystal.h. Everything right in here is comments that explains how it all works, and we're basically going to ignore for right now. You can read that at your leisure. And the first thing that we're going to do is we're going to change some of the code right down in here. Okay, because in order to initialize your liquid crystal display, you have to send a statement to the Arduino saying, hey, we're going to use a liquid crystal display, and this is how I've hooked it up. And there's a number of pins right on here. The RS pin, okay, and if you look at the board right there, that's your register select. You'll see it says RS right there. Your enable pin, and then your D4, D5, D6, and D7. Okay, so those pins all show up right in here. And we just use different pins than what they used. So for our code, instead of using RS of 12, come over here and take a look at where your RS is plugged in. Register select right there, comes up here. That was that first yellow line, came all the way over here to pin 7. Your enable was the next one. That's in blue. Your enable comes up here, follow this blue line back, and that comes to pin 6. Your data 4, DB4, comes up here. That comes into the brown line, comes over to pin 5. Okay. Then, oh, that had the right number in there. 5, 4, 3, 2, all the way down there. So now we set these values right up in here, okay? And then those values get replicated in here. They get sent off to the liquid crystal object and say, hey, we're going to set up a screen. We're going to call it LCD, and it's going to be connected to these pins right in here, okay? Now, we have a 16 character by 2-line display. So we're going to print hello world, Okay, and then right down here, we're going to do a few other cool things. So let's just start the simulation and see what it does. And like I said, I wasn't sure on this one if we needed to hook up an LED on there or not. So let's just stop that simulation. It looks like we do. Okay, move your code out of the way right on here and just add a resistor from your positive. And then we'll just hook that in right here to the LED anode. Anode means positive. Okay, and we'll kind of make that orange. And then the LED negative, we'll bring that back to black. And then we'll just set the value of this resistor down to 200 ohms. Check to make sure that the color changes, red, black, brown on there. And let's start that simulation now. You see the light turned on the screen? Okay, nothing's showing right now on here. Take your potentiometer and turn that contrast up. And our display. There we go. This one's fussy. You got to turn the contrast all the way up. Should come up and say, hello world. And you'll notice that just beneath that, it's got some counting taking place. Let's take a look at the code and see why it's doing that counting. Okay, so all the stuff in orange is just comments for humans to read. It's the stuff in dark that is useful for the computer to read. And now we're coming in here, we're including liquidcrystal.h. So we're saying go out, get the liquid crystal library, bring it in here so that I've got additional information that I can work with, additional routines to use. I come in here and I say, well, these are going to be the pins that I'm using because I'm hooked up to 7654321 on the Arduino. Okay, my setup routine right in here. So this is all done before I get to setup. I call this our definitions and declarations, where you tell the computer a little bit about what you're going to be doing. If you think about your program as giving a speech, okay, this would be like the person who introduces you. This is your opening statements, and this is the part of the lecture that you just keep repeating over and over and over again till everyone falls asleep. That's a bad example. No? I'll keep repeating over and over until you fall asleep then. So here we go. In your setup routine, then we come in and say, okay, LCD. I told you that I was going to have an LCD and it's connected to these pins. I just want to let you know that there's going to be 16 characters across and 2 lines up and down. And then I'm going to print a message that says hello world. And that's where this came from right in here. Now in our loop, which is repeating over and over, we send a command that says set the cursor to character 0 on line 1. Now you'd think this would be line 1 right up here, but this is actually line 0, just like this is character 0. So if you think of this as your grid, this is 0, 0 right here. So this is 0, 1 right down here. And then you print a number right over top of it. And here it went to that millis command, and it went and got the number of milliseconds since you started the program, and it's divided it by 1,000. So this has been running for 34 seconds. Of course, it's been running for longer than that, but this is simulated time. Up here, you can see the simulated time is 36 seconds, 36 seconds, 37 seconds, 37 seconds down here. So now we can get data off of our computer in 2 ways. One, by sending it out, data off of our Arduino in 2 ways. One, by using the Serial.print command to send it down the USB bus. The other, by using a parallel interface to send it to the LCD screen on your Big Bad Breadboard board. Let's pop back open to the other screen right here and take a look at how I've wired up my Big Bad Breadboard board to make this all work. Okay, I'm gonna make this window fairly big right in here for right now and turn this monitor on right here. And this time I think I'm going to give it a little bit more light. Pardon that blast of light right in here. Okay, so right in here, we've got a big bad breadboard board, and we've got a real genuine 16 by 2 LCD display, and you can see that we've got some nice rainbow cable hooked up right in here. When you see this type of cable, there's a pretty good chance that you're dealing with a parallel interface because you've got lots of room for data to be transmitted across there. All right, now in your Big Bad Breadboard board kit, you've got some nice double-ended headers like this that can plug into your board right here, and you can just snap them off to the length that you need. So give it a count. There's 2, 4, 6, 8, 10, 12, 14. There's 15 pins on there that you can use. Okay, and so that's going to go in there right about like that, and line it up nicely so that it aligns with your Arduino right on here. And then you can put that in there, and that should match up really nicely with the header from your LCD display. And just so you know, let me pop this out here. These are a nice double-ended header strip. They're not the usual header strip. I really like these when I'm doing breadboarding stuff because where your standard header strips are this long, okay, this is a standard right here, you can see that I call these ones the double length because they're long on both ends. So you can see the comparison between a standard header that you'd put into a printed circuit board and the double-ended header that plugs nicely into a breadboard or allows you to connect connections together. So just pop that right in there. I find second row in seems to work pretty good for me. And that goes in there, and that should be able to plug on there. Now don't plug that in just yet because we've still got some connections to do. Okay, now also in your kit is this little potentiometer right here. And I used a pair of needle nose pliers to take one leg, and doesn't matter so long as it's one of the two outside legs on here. Let me just set that down right there. And you can see that I put a slight bend and I move that over 2.54 millimeters. Well, 2.5 millimeters. The spacing on here was set long ago at 1/10 of an inch between each of those holes, or 100th thou. And that translates into metric into 2.54 millimeters, or quite commonly referred to as 2.5 millimeters. And the reason we're moving that over one is because I don't want it going into this row right here. Okay, so this row right here, as you can see, has nothing hooked up to it. So I'm going to take these two pins and I'm going to do a little shortcut. Instead of doing the extra wiring I did on the other side, I've got +5 coming in right here to this line. So I'm going to put one side of this into the +5, and then I am going to hook it up so that this one goes to ground. So that one goes into ground. This one right here goes into the yellow line right here for controlling the contrast. And the other one comes in here to my +5. Now, when I turn that dial on the potentiometer, I can control the contrast on my screen. Okay, so let me just slide that in right there, and it now goes from +5 down to ground. Alrighty, now if you want to test that, well, we'll get there in just a minute. Alrighty, rest of my lines coming in here. You'll notice that I've tried to keep the colors of wires to match the color of wire in the rainbow cable so that we can follow this all the way through. So this first one right here, I've tucked it down underneath the edge of the board to keep it nice and tidy, which would be absolutely miserable if I didn't have different colored lines doing this. But this comes right down here. This wraps around here. Because it's yellow, I know that I can track it out, and it comes right here. This is kind of a neat way of just hiding some of your messy cabling. It's really important when you do breadboarding that you start getting used to keeping your wiring nice and neat and tidy, because when you start to get multiple wires, it can be a nightmare to troubleshoot. So if you use different colors for different signals and always do black for ground and always do red for your +5 lines, then you're going to be able to tell by looking at a wire not only what it is, whether it's ground or +5, but you can also tell where it goes just by saying, hey, look at that blue wire. It goes down underneath here. I lose track of it, but it comes out on this side, and there's a blue wire going right into pin 6. So we're going to hook this up just like we did on the computer. Okay, the simulation is going to run exactly the same. And down here, I've got brown, orange, white. We don't have to hook up the LED button lights in here because this one doesn't have an LED. It's actually got something called an electrostatic display, and it requires a higher voltage driver to run. And quite frankly, we don't need it. Alrighty, we've got that in right there. Gonna plug that in. And oh yeah, it's still got the serial print routine on there and it's printing away. And so we've got this all wired up on here. And now what I'm going to do is open my Arduino IDE. And let's see right here. I need to get this set up so that it can be seen what I'm doing here. Move this right over here onto this side of the screen. Okay, now I am just going to turn this off for a second. So I can come in here and I can take this code that I've tested right out in here. I can highlight that code because I know it's working and I've adapted it to use my commands. I can copy that code and I can go into the Arduino IDE and paste it to overwrite my old code. And then I can upload it to my Arduino. And to see the results, let me turn that back on. And it's always fun because now I'm recording this for an audience and it should work, but there we go. There's our uploading. Done uploading, and I should be seeing something appear on that screen right now. Now, if I'm not seeing that appear right now, it's possible that my contrast isn't set up just perfectly. So you may have to take a small screwdriver and swing your contrast back and forth a little bit. This should be hooked up right in here. And why does that not show up on there? Somehow I think I had this resistor in here the other way around before. Red, black. This yellow line at some point got plugged into the wrong hole. Okay, so if you've got something in the wrong hole and it's not plugged in correctly and it doesn't appear to be working, don't panic. You're not the only person to ever get something plugged into the wrong hole. Take a careful look at what you're doing, compare it to the screen that we just had where things were working and saying, okay, what's different on here? Being one hole off means that I was sending that signal to the wrong place. If I plug this in here right now, plug my LCD screen in, I may have to hit the reset button. The Arduino has a reset button right there to start it up again so that all the timing is in sync. And now I should be able to adjust my contrast. Okay, now I've got something appearing down here. This is a good start. That means that I'm getting power to the screen. I'm getting contrast. I can control the contrast with that potentiometer, but I'm not getting data appearing in there just yet. Let's see why I'm not getting data appearing in there just yet. Press that reset button again. Not quite. Maybe another wire got bumped around on here. Notice how that flashed off all of a sudden? Okay, look for clues like that. That means you might have a loose wire somewhere in your system. So you can take that off and you can take a look again. Looks like everything down in there is nice and tight. Looks like that potentiometer is in there. Good. Make sure I align this right in here and all my data matches up to where it should be going. And not quite just yet. So play with that. There it goes. You want your contrast to be somewhere just below where it's all solid black in there. It's a little fussy to get that tuned in there. Okay, so if you're seeing that, don't panic. Okay, sometimes things don't work the first time out. I'm just going to take a quick pause and take a look, and then I'll tell you what was going on wrong here. Well, sometimes I'll try to make something fail just so I can share with everybody that we all screw up from time to time and we go through and troubleshoot things and we solve them. That one was not intentional. I had my mind on other things and as I was going through here, but as you can see right down here, it's now working and we've got our display working. And what it was, let me just pop this off right here, was when I was hooking it up, I was looking too much at the hookup on the Tinkercad screen. And on the Tinkercad screen, because I set the potentiometer up over here, just because of the way Tinkercad was set up, I forgot that by doing it this way, I actually have the middle pin for the contrast coming through right here. And on Tinkercad, that's a green line that we're showing coming into this third pin. And I thought, oh, I've got nothing hooked up there. And so I probably had a loose wire to begin with, and then by fixing it, I moved this over one, and that set me back a little bit and left me confused. So anyway, when you're looking at this, you should go black, red, and then a space right here because that will be the middle pin of your potentiometer. And one side of your potentiometer will be tied into the red side right here. One side right here has that little extra bend in the leg, so it's actually tied in right here. Okay, so you can see there's a bend on the leg. It comes across, comes in here, so it ties into the ground. So the potentiometer is split between +5 and ground right here. Well, you know you've been recording videos for a while when even the headphone batteries die. So anyway, as I was saying, I made a mistake because I had this yellow and I thought I corrected it by moving it over here, but it was in the right pin. Aside from that, I went through and re-wiggled all these pins to make sure they were in nice and tight. And now when I put this together, well, I just plugged that on there and I'm getting weird characters popping up here, which is a really good sign. If you're getting weird characters, that means you have communication. And what you probably need to do is just press the reset button on your Arduino right here, and that will resync all of your parallel lines, and it'll get your data down on here, and your hello world will show up on there nicely, and you should be seeing that. So there we go. We've got a couple of different ways of getting data off of our Arduino. We've got Serial.print that comes out here and goes back to the serial monitor on your computer. And then we've got LCD.print that comes right up here. When you're working in the Arduino code, you will find that, let's take a look at your IDE right over here. Okay, your Arduino IDE is sitting right up on here. And what you'll find is that in your examples, you've got lots of other examples for your LCD display. So if you come down here and in your examples and come down to liquid crystal, there's there's a blink routine that you can try. There's a cursor routine, custom characters, scroll. Let's just try scroll and you'll get a window that pops up right here. And if you want to try that code, just remember that we use different pins than they do. And so you can change this up and we are RS is 7, not 77. Enable is connected to pin 6. Data 4 is connected to 5, 4, 3, 2. So you just need to change those 2 pins because of the way we're hooked up in here and upload that. I'm on the wrong COM port now. I tried a different Arduino, switched to a different COM port to do that. Always check your COM port and go back to Device Manager if you're not sure. And go ahead and upload. And now you get Hello World scrolling back and forth across the screen. Now, if that's not quite showing up bright enough, you might just come in and take a fine little screwdriver and tweak that contrast up a little bit. And there you go. And then take a look down at the bottom to see how it goes about doing that. There's all sorts of examples of cool things that you can do with your LCD display. Have a good one. And if you run into a problem, don't panic. We all run into various problems on here, okay? And it's just a matter of taking a look at it. And as you develop some experience, you'll be able to say, okay, I am going to solve this. Work it through and let's see how it goes. For those of you in my class, you know how to get in touch with me if you're having problems that you can't solve. Have a good one.